to my tutorial again. So already I have uploaded many videos of 9th class about your language of chemistry. Today I am going to teach you some new concept about language of chemistry. So please stay tuned with my channel, and whatever I am writing in the board, that you note down always. So let's start our topic without wasting the time. Now children, let's go to our topic. Today we will discuss about the naming of the acids and bases. So first of all, let's discuss about how to name different type of acids. As all of you know that, what are the acids? Which are containing hydrogen. But containing of hydrogen is not sufficient. If that compound will dissolve in water and produces hydronium ion. Actually, it releases H plus ion. After mixing with water, it will turn to hydronium ion, means H3O plus ion. That time, the compound will be considered as the acid. So, acids are the different types on the basis of different things. So, here we will discuss about how to name that acids on the basis of what. So, first of all, we will read about the how to name the binary acids. So, what are the binary acids? Binary acids means, as per the definition of the acid, that compound must contain a hydrogen element, and other than hydrogen, another element must be there. That time, it will turn as the binary acid. Element is there, remember. Other than hydrogen, if another element is there, then it will turn as the binary acids. For example, hydrochloric acid, hydrobromic acid, hydrocyanic acid, hydrofluoric acid, like this. So now, let's see how to name. As I have told, hydrochloric, hydrobromic. So how will you know that whatever I am telling hydrochloric, how it came? Let's see how the name came. Now see here. Names of binary acids are given by prefix hydro. Prefix hydro, as I have told. HCl means hydro. First hydro will come. That is called prefix. After that, whatever the element is there, that will come. Means if HCl, hydro will come. Then after Cl element is there. And from Cl, chloro will come. Then after chloro, what is there? And suffix is ic, means with chlorine, you have to put ic. So it will turn as the hydrochloric acid. Now see again. H means hydro, as I have underlined. Chlorine means chloro. Ic means ic, chlorine and acid. Like this. HN. H means hydro. F means fluoro. Then suffix is ic. Then fluoric acid. It will turn as the hydrofluoric acid. Now go to the how to give the name to the other acids. Suppose a acid contains a radical. Then how to give that name to that acid? Or polyatomic groups. Poly means many. Atom means, atom you know that is the polyatomic, means more than one atom. As I have told in binary acid, there other than hydrogen, one element is there. But here polyatomic is there, or radicals are there. That time how to name that acid? Let's see. Acids containing radicals or polyatomic groups are given on the basis of the second element and suffix is ic. In that element, after hydrogen, whatever the second element is there, you have to put that element. According to that element's name, you have to give the name of the acid. And suffix is ic. Hydro should not be used. Now see the example. H2SO4. Other than H, second element is sulfur. That's why from sulfur, the name will come. Sulfur means it is the sulfur and the suffix is ic. So that's why sulfuric, then acid. Like this. H2CO3. The second element is carbon. Then suffix is IC. So it will become carbonic acid. Like this other names also you can give. Suppose H3PO4. So your P is the phosphorus. You have to take the second element phosphorus. Then IC, you put the suffix. Then phosphoric acid. Like this, you can give the names of the acids who are the binary acids and who are the acids containing the radicals and other polyatomic groups. Now see other common names. Now children, let's see those compounds who are not following any systematic rule for their naming. These namings are called trivial names or common names. So let's see the compounds. For example, ammonia. Ammonia is a combination of two elements, nitrogen and hydrogen, and it is not following any systematic rule for its naming. That's why the trivial name has given ammonia. Like this sugar. Sugar is a combination of three elements, carbon, hydrogen and oxygen, but it is not following any systematic rule for its naming. That's why common name had given sugar. Then urea. It is the combination of nitrogen, hydrogen, carbon and oxygen, but it is not following any systematic rule. That's why the common name has given urea. Like other examples also I have written. Go through the examples. If you will get, many of the examples in any other reference books from any other your sites are there. So many other elements are there what are given the common names because they are not following any systematic rule for its name. Now let's see how to name the bases. Before that, you note down the points. Now children, let's see about the bases. What are the bases? Bases are considered as which contains generally OH radicals, generally. But the other definitions of bases are there also. But here, how to name the bases which are containing OH radical? What is the name of OH then? Hydroxide. So, whenever you are naming a base containing OH radical, then after the metal, you have to add only hydroxide. For example, NaOH, Na means sodium, OH means hydroxide. The name is sodium hydroxide. Like this KOH, K means potassium, OH means hydroxide, so the name is potassium hydroxide. CaOH whole 2, Ca is calcium, OH is hydroxide, so the name is calcium hydroxide. MgOH whole 2, Mg is magnesium, OH is hydroxide, so the name is magnesium hydroxide. Like this, other hydroxides also you can give the name. So, this is the procedure how to name the acids, bases, and which are not following any systematic rules, they will be followed by the trivial names. Now go to how to name the compounds, how to form the compounds, what are the chemical formula of the compounds, and what about chemical equations. In my later videos, I will tell. Now children, let's discuss about how to name the compound. Already in my previous videos, I have discussed how to name the compound. Here, I have made one table to make it easy. So, before starting this, just I want to put a glance on that video. There I have told how the compounds will be named. You have to exchange the valences of the metals and the non-metals and the radicals. So, here I have written some metals name and some elements and the radicals name along with their valences. How to exchange the valences? You just learn it again and you write it in one place so that it will be easy for you to remember. Now let's go through one by one. Here I have written some metals name: sodium, potassium, magnesium, zinc, copper, iron, calcium, lead, aluminum, iron. So here valences also I have written. Some anions name: hydrogen, fluorine, chlorine, propene, iodine, oxygen and nitrogen. elements I have written. In this table, I didn't write about the radicals. Only elements I have written. So, these elements along with the valencies also I have written. Hydrogen 1 minus, fluorine 1 minus, chlorine 1 minus, bromine 1 minus, iodine 1 minus, oxygen 2 minus, and nitrogen 3 minus. And how to name it? Hydrogen means hydride, fluorine means fluoride, chlorine means chloride, iodine means iodide, nitrogen means nitride, and oxygen means oxide. So how to write this one? Now see that one. Here, one is there. First rule is that wherever the cations and anions having same 1 plus 1 minus, 2 plus 2 minus, 3 plus 3 minus, there it is cancelled. Other than the same, if they have the different value, then it will be exchanged. Means your cation valency go to the anion valency come to the cation. Just exchange it. Now write the names. See here, Na1 plus H1 minus. As I have told, 1 plus and 1 minus is cancelled. That's why it will become NaH. Like this, 1 plus 1 minus will be cancelled. It will become NaF. Like this, 1 plus 1 minus cancel, it will become NaCl. 1 plus 1 minus will be cancelled, it will become NaBr. NaI, same formula. Then here you can see 1 plus is there, 2 minus is there. So different valencies are there. Now you have to exchange the cation valency and the anion valency. Means the 1 plus of Na will go to O, 2 minus of O will come to Na. So no need to write 1. So just you can write it Na2O, because O is the valency 2, it will come here. N is the valency 1, it will go there. No need to write 1. So that will come as the Na2O. Like this you can put 3 is there, 1 is there. 1 will go to N, 3 will come to Na. So the formula will be NaCN. NaCN. Like this. Same K you can put because both have the same valency. So in the same formula you can put KOH, KF, KCl, KBr, Ki, K2O, and your K3N. After that, magnesium is having valency 2 plus. Here you can see the valency is the 1 minus. So valency is different. You have to exchange it. 1 will come to Mg, 2 will go to H. So the formula will be MgH2, MgH2, MgCl2, MgBr2, MgI2. Then here the Mg2 plus and O2 minus, same valency of the cation and anion, that will be cancelled. So it will turn as the MgO. Now what will happen? Here 2 plus 3 minus, it will be exchanged. So it will turn as the Mg3N2. The 3 of N will come to Mg, 2 of Mg will go to N. So it will become Mg3N2. So here you can see I have written sequential wise what are the 2 plus valencies are there. So same formula you can apply and same format only you can write other compounds also. So put it MgH2 like this, ZnH2, ZnF2, ZnCl2, ZnBr2, zinc bromide, ZnI2, zinc iodide, ZnO, Zn3N2. Like this Cu, CuH2, CuF2, CuCl2, CuBr2, CuI2, CuO, Cu3N2. Take Fe2 plus, FeH2, FeF2, FeCl2, FeBr2, FeI2, FeO, Fe3 and 2. Like this Ca. CaH2, CaF2, CaCl2, CaBr2, CaI2, CaO, Ca3 and 2. Pb, don't write this hydride because it is a complex hydride. It will form in the another way. So here is the PbF2, PbCl2, PbbR2, PbI2, PbO, Pb3 and 2. Al. Now you can see. This is 3 plus valences I have written. 3 plus and 3 plus. So this 3 plus, this 1 minus, again the valences are not same. You have to exchange it. So what will be exchanged? So 3 will go to H, 1 will come to Al. So it will become AlH3. Again it will come AlF3, AlCl3, AlBr3, AlI3. Then this one, O is the 2, Al is the 3. So 3 will go to O, 2 will come to Al. So it will turn as Al2O3. Then nitrogen. You can say nitride. C and C cancel. So it will become ALN, aluminium nitride. Then after Fe3 plus, same 3 plus will be formed in the same format. So you can write FeH3, FeF3, FeCl3, FeBr3, FeI3, Fe2O3, and Fen. So these are the compounds I have written here. After that I will form the same metals with the radicals. So before going, let's read once. What are the names? Hydrogen means hydride, fluorine means fluoride, fluorine means fluoride, bromine means bromide, iodine means iodide, oxygen means oxide, nitrogen means nitride. IDE. If single element anions are there, the suffix is IDE. This is the key point. If single element anion is there, suffix is IDE. So with metal, whatever the element name, you just put IDE. IDE. Sodium chloride, sodium bromide, sodium iodide, sodium fluoride, sodium nitride, sodium oxide. Like this with other metals also, you can put this suffix. Now, you also make this table, and the next table, what I am going to teach you, that is your metal with your radical. Now children, let's see how to make the compounds with radicals. So whatever the formula I have told, that same formula will be applicable here. Only thing is that you have to remember the formulas of the compounds and their valences. Which compounds? Radicals. You have to remember. No option is there. So if you know the formula of the radicals and their valences, then easily you can make the compounds. Now see how to make Na1 plus OH1 minus. First let us read. OH means hydroxide. HCO3, hydrogen carbonate, or you can say bicarbonate. If hydrogen is present, then you can put the word bi, hydrogen carbonate or bicarbonate. HSO4, bisulfate, PHATE, or hydrogen sulfate. NO3, nitrate, ATE. CO3, carbonate. If H is there, bicarbonate. If only CO3, then carbonate. SO4 sulfate, SO3 sulfite. Now same formula you apply and make the compounds. If same valencies there, it will be cancelled out. If opposite valencies are there, then you have to put accordingly. So now write the names and this one NaOH, because here 1 plus and 1 minus is cancelled. After that 1 plus 1 minus is cancelled, that is the NaHCO3. Same 1 plus 1 minus is cancelled, NaHSO4, then NaNO3. Then here valencies are different, so you have to write Na2CO3. 2 will come here and 1 will go there. So it will turn as Na2CO3. Then it will turn Na2SO4. Then it will turn Na2SO3. Now K. As K is the same valency as Na, so you can put the same format. Only except of Na, you can put the K. Now write this KOH, potassium hydroxide, KHCO3, potassium bicarbonate, KHSO4, potassium bisulfate, KNO3, potassium nitrate, K2CO3, potassium carbonate. 2 will come here, 1 will go there. Then like this K2SO4 potassium sulfate, K2SO3 potassium sulfite. Now go to the two valencies of the metals. I have written it sequential guys, so it will be easy for you. If you write one compound, then you can write others also. So Mg2 plus, here 1 minus, so that's why it is exchanged. So it will turn as MgOH2, magnesium hydroxide. Like this you can write zinc and others also have the two valencies. So ZnOH2, zinc hydroxide. CuOH2, copper hydroxide. FeOH2, ferrous hydroxide. CaOH2, calcium hydroxide. PbOH2, lead hydroxide. Now 3 valency will come. So 3 valency means yours is again exchanged. AlOH3, aluminum hydroxide. FeOH3, ferric hydroxide. Same format will be applicable for the 1 minus valencies. Now see, in the same format, MgHCO3(2), magnesium bicarbonate. ZnHCO3(2), zinc bicarbonate. CuHCO3(2), copper bicarbonate. FeHCO3(2), ferrous bicarbonate. CaHCO3(2), calcium bicarbonate. PbHCO3(2), lead bicarbonate. Then after AlHCO3(3), aluminum bicarbonate. FeHCO3(3), ferric bicarbonate. After that go to the here same format, MgHSO4(2), magnesium bisulfate. ZnHSO4(2), zinc bicarbonate. CuHSO4(2), copper bicarbonate. Bisulfate, all are the sulfate. Then after FeHSO4(2), ferrous bisulfate. CaHSO4(2), calcium bisulfate. PbHSO4(2), lead bisulfate. Aluminium HSO4(3), aluminum bisulfate. FeHSO4(3), ferric bisulfate. Like this, it will go to the NO3. So here 2 and here again 1. MgNO3(2). Then ZnNO3(2). CuNO3(2). FeNO3(2). CaNO3(2). PbNO3(2). AlNO3(2). FeNO3(3). FeNO3(3). So like this, you can complete other tables also by putting the 2 minus valencies. compound, what is there then? Na and CO3. So it will turn, if it is 1 and it is 2, then it will turn as the Na2CO3. Like this, Zn2, sorry, this is the 2 to cancel. Here you can say, sorry, it is Mg. Mg and CO3, so 2 to cancel MgCO3. ZnCO3, carbon. Then after Cu, CO3. Then after Fe, CO3. Then after Ca, CO3. Then Pb, CO3. Then it will come Al, and this is the 2. So Al2, CO3, whole 3. Fe2, CO3, whole 3. Go to the sulfate, SO4, same format is there. You can complete this table from Mg, SO4, then after Zn, SO4, Cu, SO4, Fe, SO4, Ca, SO4, Pb, SO4, then here Al2, SO4, whole 3. Then Fe2, SO4, whole 3. Like this you can complete the last also. What is the SO3? Mg, SO3, magnesium sulfide. ZnSO3, magnesium sulfide. Cu, SO3, copper sulfide. FeSO3, ferrous sulfide. CaSO3, calcium sulfide. PbSO3, lead sulfide. Al2, SO3, O3. Like this, Fe2, SO3, O3. So these are the compounds of the metals with the radicals. Again, if more radicals are there, you can make the compounds by putting this same format. So if you will write in one table, it will be easy for you to remember. Now note down this table for your understanding, better understanding, and easily remember. Okay. Now children, this is all about today's topic. In the next video, I will tell you about the chemical equations. So, before going, as always I am telling, to subscribe my channel and press the bell icon to get the latest notification of the videos, and stay tuned with my channel.